So, if there are no other things to discuss, then we can discuss this practical exercise about collections. So here in this web page about tasks, there is not much information given to us. We need to investigate activity 09 and we need to implement classes to pass unit tests, order and orders. And if we investigate these classes, we see a lot of to-dos here for order class and lot of to-dos here for orders class. Why this guide suggests to start with order? Because the order is independent class and orders depends on order class to be implemented. Here data structure is already given to us, but we need to implement many methods for these data structures to be sortable, to be sortable, comparable, that hash code and equals work properly, etc. So first thing we need to do is we need to implement comparable interface for this class. And then we get compilation error because we need to implement needed methods. And we can allow to compare this current order object to something else in two different ways. It can be comparable to any Java object, and then signature is implements comparable, and compare to method takes any Java object for comparison. Or we can implement it in different way, so we also can add type parameter to this comparable interface, that it will be comparable only between order elements or order objects in jargon. And then when we add unimplemented methods, difference is following, that compare to method allows to pass only order objects as a parameter to it. I will not implement it yet because I will show you that to be more efficient, probably we can rely to other implemented methods. Then we need to implement following methods for order class. And as usual, I will try to use these requirements as input for my code. And here we have another set of compilation errors because we need to this is already done. Here we need to return something. Here we need to return something. Here we need to return something. And that is all these methods what are required. But as you will see here, that actually all of these methods could be also generated using code generators. For example, the string can be generated, constructor which takes parameters could be generated, and I will show you that also this and that also could be generated. We only need to know what to generate. And for example, for the string, we need to take all the values, but format actually should be look like this. So first is item, which is name field for us. Order name actually is customer. And then there is count. Then constructor can be generated for all fields. Only difference is that what I catch it here, where is constructor? We need to take integer as an object instead of primitive type. But nothing else should be changed here, because when we assign it to primitive type, value of this primitive type stored inside this integer object is automatically taken and put here in this primitive integer. And then we can also generate hash code and equals methods. And here we see that orders are considered equal if item, customer and count is the same, and not equal if there are some differences. And what was missing, I don't remember. Hash code equals order compared to. I think this is somewhat done. And we see here order design test. All methods are here, so that's done. But compare to returns error. And what is wrong here? What is compared to? It's not implemented. Yeah, so now about this to do. One of thing is following, that equals is more complicated than compared to is more complicated than equals. Okay, so we will implement it by ourselves. And how we need to compare it? We need to compare it in following way. I will just copy it here to better see. So we need to start comparing by item name, then customer name and count of items. And remember, this is string, this is integer. And comparison for all of these types is already implemented. We can compare them, and we can start something like this name, which is actually it name, compare to, and I will call it other. And then I will get result to compare name of current item with name of other item. But that's not all, because they may be equal. And therefore I need to check, for example, what is current status. And the status may be that they are both equal, it's still the same item. And then we need to check more, so if status, so these are equal, status will be 0. We need to do compare customer. Other customer. And we still will need to remember it. And here are two schools of thought. Some say that you never should reuse some variable for different roles because it's harder for debugging. But if only thing I needed to remember is in this case and decide what about this, I tend to reuse variables because then code works a little bit faster because it takes a little bit less memory. And of course it's a little bit harder for debugging because first I assign status here to compare this, and then I reuse the same variable to compare it here. And then again, also customers may be the same, and then status will be 0. And then we need to compare count. And it's primitive type. How can you compare primitive types? There is no compare to method for this. But we can do something like this. Status is count minus or complete opposite. But I think I need to discount from this other, because if it's negative, this is larger. This should be before that. I don't know about order of these things. And then return status. And that's how you compare these fields by fields, by reusing compare to method for already implemented types, or for example for numbers. And now if we run JUnit test, we see that order design test is passing and order test itself is also passing. And you may leave it here if you like, but you may try to make this code shorter and easier to maintain. And here I see I can remove one appliance here because I tend to make code shorter. For example, here we again use some kind of hashing here. And we also use a hashcode method for strings here. And it works pretty fine. It's not very slow. But if you know what you are doing and you add some small coupling here, and if you know that here the string method actually returns all data which are needed to check for uniqueness, you can take it much shorter and return something like this. First, convert it to string, and here all these data will be put together, and then compile hash code for this string, and of course return it. I'm not saying that you should always do this, but what I'm saying is that this code is much shorter and will not work slower than that code, because you see here hash code for customer is executed, hash code for name is executed, some of calculations are done here. And definitely this code is shorter, only not so good thing is that of course we call method from method, but I think we can live with this. And now about this method. Again, this method in general works, but there is quite a lot of code, and for maintainability purposes we can make our custom written code shorter and easier to understand and maintain, because this is another example where generated code probably is not the best possible code and definitely not the shortest code in the world. Because if we have implemented compare to method, we already know that if the status is 0, these two different orders are considered the same. Similarly, if the string, if it has the same values, it is the same. So here we can do something like this. If compare to is 0, then we return true. But this method is more general, because here we take only orders, and here we have to take any Java object, and therefore we need to do some checks before. If where was I? So if this is 0, and then we can actually make it even shorter. So if this other object will be instance of order, then we can downcast it to order object, and we can use compare to method, which is already implemented, to compare them. And if this method will return 0, this means these are equal, we return true. For everything else, type is different, value is different, etc. It will not be equal, so we return false. And this is just another case where you can see that generated code is not always the shortest and maybe sometimes also not the fastest one. Again, here we do some small coupling, we use compare to method, but I think in terms of maintenance, this code definitely looks nicer than that generated code. And then utility methods like the string tends to be at the end of code, and then we can live with something like this. And now our order objects are sortable, comparable, you can convert them to string, and they have unique hash code for unique values, the same hash code for the same value. Now we can go to the orders class. Here again, it's hard to say what will be shortest way. We need to implement iterator with orders class, so that would be first do in iterator, and we need to import it, and then we need to implement unimplemented methods. And what about parameterization? Also it will be iterating over order elements, and then return type will not be object, but it will be order. So not everything is implemented, but I will mark it as done, because here we see that we have another to-dos here. And what is business requirements or logic behind this orders class? So orders class may contain many orders inside it, and it works like a aggregator or collector of these separate single orders, and you can do different kind of management operations for them. You allow to add new order for it, you can get list of these orders, you can get set of them, you can sort this list, and you can iterate through this internal list of these orders. So this is something like a bucket for our orders, and this bucket is called orders in plural. So what is easier, to generate them or to create them from here? I don't know. We will try this approach. All these, I think, should be public. Then, of course, I have missing return statements. We need to import list from java.util package, and we need to add return statement. We need to import set from java.util package, not from these other packages. And we need to add return statement. This should be set to void. This should be already declared. This already declared. This should be void. And this should add return statement. And something is still not right. They have too many brackets. So list is done, implementation is not done, but I will remove that one. And here this comment probably should go somewhere before constructor. So to use this orders class as a bucket for order elements, we need to store them. So that means here we can make it private. Some kind of list, and we will parameterize it so only order element can be stored inside it, and we will call it orders. And when we construct this bucket, and here we need to choose something, and I will use linked list. And here I also need to add type parameter and need to import linked list from Java OTL package. And more or less this to do is also done. This should be somewhere probably after constructor, somewhere here. And we can check our design. By running JUnit tests, orders, design test is passing, and of course actual tests are failing because nothing is implemented. So now we need to think about implementation. One of things how can we implement this iterator is by ourselves. We saw how something like int index. And when we construct it, not here, but somewhere here, we say index is before first element, and then we do return something if index smaller than orders size, return true, else return false. Then for next we say index first, we increase it, and then return orders index. Get or something like this, get index. And here we have to say something like orders add item, and maybe that will work. And here you say something like orders the remove index. And in general, that would I think about add index and item, something like this. But this is just a proof of concept, because here we don't have any error conditions checked. For example, what happens if we are already at the last element? So here we have to throw some kind of error. Instead of just getting index too big, we need to throw I do not know what. Similarly here, if this index is too big, we cannot add element in this place, we need to throw some kind of error or exception or whatever. Similarly here, if index is out of scope of current list, we need to throw some kind of error. And you can test it out by yourself if you are curious. See, for example, no list is actually created yet, its size is 0, and we get index out of bounds exception, which is wrong, because index out of bounds exception is something like for array. It should have something different. And therefore, Accenture thinks and MIT that you had to know how to implement iterator by yourself, but for me, I think it is too much of work, and therefore instead of integer index, we will cheat a little bit and we will introduce private because iterator is already implemented in Java in iterator class. And again, it's row type, we need to say it's iterator over order elements. And then instead of using this index, we will say that our iterator is orders get iterator in following way. And then instead of our manual solving of all these things, we just return as next. Here we return iterator next. Here we return don't remember. Maybe we add the end here without iterator. Of course, return here. And orders remove. Here is to remove. In such way. I don't know about this particular implementation. Remove. I think this is correct one. We will test it out, and if something will not work, we will update. And then we are just exposing this our encapsulated Java iterator, maza iterator in our iteratable custom class. And I think actually if you don't need to learn how iterators work, from design perspective this is much better design actually. So our list here, get items list, we return orders. Here for sort we say, about sort, you may go into wrong path here, because you may see orders.sort, and here you see that you need to pass reference to the comparator. And that is wrong path, because reference to comparator is needed only if you want to sort by not native order. And we don't need this because we already implemented native sorting order by implementing comparable interface. And then you can Google it by yourself, but I know it already, and here are some hints. That to sort properly you use collections sort and ours, how it's called, orders, and then it uses native sorting order, and this is proper way how you sort by native sorting order. And here I think there's also a hint. We just need to show how many orders are inside our bucket called orders. List to string, and this list for us is called orders to string. So if somebody will convert orders to string, it will actually show what orders are inside this bucket or collection. And when we test it out, we see some errors, and we can resolve them one by one. First file or trace is that if there are no orders, empty set should be returned instead of null. And where it is, get items set, it's not implemented yet. But okay, we can solve it a little bit. We can say something like set of orders set is new imply parameters and reset comes from not orders, set of order. So that is implemented. Now about iterations, we get concurrent modification exception. And what is here talk about? Let's search for Java 11. And what does it says? This exception may be thrown by methods that have detected concurrent modification of an object when such modification is not permissible. And how does this happen? It happens in following way, that here we call orders. where exactly and here we call next, but before that somewhere here is called, and maybe also sort or remove. So what do we see here? That we call orders then several times and what does it mean? We have initialized this iterator here only in where's constructor here, and then after that time it happens here in next method. After many adds, next method is called, and this is considered wrong because how it happens, I have first empty list, so no elements at all, and I initialize my iterator here. And then I have added 1, 2, 3, 4, 5, whatever many elements, and I do next. But what is required here is that after you initialize this iterator and you call next, your collection actually is not changed. So you have to have full collection already created, and only then you actually have to initialize this iterator, and only then you can call this next. It may happen, of course, if you have concurrent execution from separate threads, but here we don't even need concurrent execution. So standard iterator allows you to iterate only when you initialize it, and when you do iterate through it, it is not changed during this time. Also, if you will call some next for iterator and then add method to add something in between, this iterator will be offended again. So what can we do about this? In this particular case, when everything works in sequence, and we see that actually we have many adds and only then some next is called after all this list is prepared, we may not even initialize this iterator here at all. We may initialize it only here. But we will be safe because never know for sure that, because we see that actually many adds are, that after last add, when it will be called, our iterator will be resetted to initial state again, and it will not be offended. And for symmetry, we may do like this. For remove, I think it's because we do it through iterator, it already knows that list is shorter. We don't need to do this. And for sorting, it also looks like we don't need to. But if we will get some error, we will reinitialize this iterator here also. So problem here is that for iterator to iterate, during iteration, this collection shouldn't be changed. And if we do in steps like initialize iterator first, then modify this list, and then try to iterate, it will throw this kind of exception for us. And so that's about this particular. And if you implement by yourself, you may implement it properly, you don't care was this list changed or not, you just allow to navigate through indexes, and you would not have this particular problem, but you would have these other problems to know exactly what kind of exception should be thrown if has next is called and there is no. Here it just returns false, but for example, if next is called and there is no next element, then you need to test out what kind of exception should be thrown there, so you would have other set of problems. And I think that knowing about how iterators work and requirements that during iteration, or in our case during initialization and iteration, this collection shouldn't be changed. We just deal with this, and I think if we are constructively lazy, we can even remove this initialization here, because no, then we have this problem that iterator should be also initialized for empty list as well. So then we deal with this, initialize it here for empty list, but every time we add new elements, and because we know, at least during testing, that it's not doing it in mixed state, like iterate few steps and add something and iterate and continue iteration, we just reinitialize this iterator for changed or updated list after these changes. And now only thing what is left here is to implement getItemsSet method, and this is to do number 4 in this list. And what are requirements here? Requirements are following, that if we collect a list of different orders and we sort it, and these orders may be like duplicates, we do not consider them real duplicates. This means the same customer asked for the same item more than one time for the same amount of items. So we collect these requirements from our customers, and then of course when we deliver this to save our money, we need to get these items from our suppliers, and of course we do not ask to ship everything just one by one from our suppliers. We want to get a bulk order for everything what we need to make our shipping costs smaller. So in general, this is how retail and vairumtirdzniecība, mazumtirdzniecība works. We make larger collected orders from our suppliers, and then we provide these items in smaller portions to our customers. And some of you who may some experience may think that to do this properly we need something like relational database, because it is tricky business, we need to do some queries, etc. But here we will see that if we have ordered list of items and properly ordered list of items, we don't need anything else, just iteratable and sorted list, and go through it from the beginning till to the end. And so we go through this ordered list, and just a reminder that it is not accident that when we had to implement this sorting compared to, we first compare by item name, and then by customer, and then by count. And because of that, when we sort our orders list, we will have first one item grouped together, then other item grouped together, then other item grouped together. And only thing we need to do iterate through them. If it's still the same item, if customers are different, add these customers to list to remember for different purposes and count total here. And I usually tend to write such kind of iterations with iterative approach. And first thing what we need to do is to understand business for infinite list, because for infinite list it's very easy. We are, let's say, doing with item 1, which is block 1, and we add this item 1 into our current item, and when we take next, we remember it as a previous item, and if name of item for previous is the same as for next, we now check customer and add, for example, here is 1, 2, 3, 4, 5. This is a number of items. So we start with 1, then this is still the same item, we need to add 2 in this current list. So for current we still have block, we have maybe some customers, but we have 3 here, and we say the previous item was this item number 2 now. Then we go to next item, check name is still the same. For this previous item we add another, maybe add customer if it's needed, and iterate. And if it is different item now, we are done with block item, and we add in total in our set here. So block item, customers blah blah blah, total amount is I think 6. And then we start with other thing. So this is if our list is infinite, there were some different items before that, and there will be some different items after that. What we will need to see is how we start with first item in the list and how we can deal with last item in the list. And I would call these entry conditions and exit conditions that we will need to implement. So far with me, business is understood. So what do we need? We need some order. Let's call it current. To make replacement easier, if I add some prefixes, I try to make these prefixes in the same length. And here, if this list is iteratable, this means we can iterate through it very easily. And we do something like current order is next. And then we need to do some checks. If why doesn't auto prompt for me? Here again, this may be null or whatever, I don't know yet. Let's make it null initially, and then of course we cannot compare previous order, particular field of this previous order, because reference is null. So if it is null, and I will try to get name out of this, it is name, I will get null pointer exception, but I can do in opposite direction. And in such case, if this will be null, it already will return false, and I will not need to go into this name in more details. And similarly, if you compare with literal value with string, you tend to do something like this, because this will always be your literal value, no null here, and if there will be null here, again you don't need to compare them. So what do we need to do? We need to check if this previous order contains customer contains customer from current order and not contain, but if it doesn't contain, then we need to add it to this previous order. I think something like this. And then we aggregate results. So this previous order count is added with current order count. So that would be adding customers if they are needed, counting sums if it is the same, but then there's else, not the same. Then we have finished with previous order, and then we say order set, add previous order. We have done with this, and then I don't remember how to do this. We need to reset to previous order. I think somewhere at the end for this cycle. Is current order. So here we just add. Can we collect everything to? We need to do it somewhere here. So we have done with previous one, and here when we do this, we add new item name in previous order, we add first customer in previous order, and we add initial count coming from this. And of course here we need to do it some iteration while next. And something should be working here. What will not be working is setting initial and final conditions, and we can test it in two different ways: manually or by using JUnit tests and trying to understand what exactly is wrong. If we do it through the JUnit tests, we run them. What could we do here? I don't like this, because here, if somebody is allowed to add such stupid orders, like nothing is required, customer is empty, 0 is empty, probably we will also send such bulk order to our suppliers. But I will use, this is just a workaround. It's not very good, but it is just to make this working properly without null pointer exceptions. And we see here that here we saw this stupid order, no item, no customer, no required items created. We will need to fix it, but at least now it works that we can test it. And we see that in between of this list, like infinite items before, infinite items after, or at least one before and one after, this particular iteration works pretty well, except order is different, customer 1, customer 2, but we have 3, 2, 1. So what is missing here is called sort method. And now everything is more or less okay for items in between list. But we do not have last item printed out. What can we do? So here we need to add one last previous order. This is when list is finished. List. And now we have everything more or less working up to this stupid workaround, as far as I can tell. And what can we do? So I don't like this particular approach, and it should be, I told you, nulls in general shouldn't be used, but internally, if you do not want to throw internal exceptions, it's still okay. You shouldn't return them outside of methods, but inside methods it is good. So here we do something like this. If previous order is not null, and here I use this shortcut and, so this will not be evaluated if this is null. And now I got null pointer exception. It is good question where exactly. Get item set from empty list. While has next. Okay, we will do our manual test here. Oh, this is null. Okay, we can add another if pre-order is not null. still we got some null. Okay, let's redo our manual test. So it is empty. Let's double check. So then we have so this is more tricky. And when you see stack trace here, next item. What is about here when it is called? Okay, as a workaround, I'm lazy to debug it. I will add set add also this only if it's not null. And now it even works. And if it works, we can delete, for example, debugging code, this one, this one, this one. And if we are not tired yet, we may now think about optimization. And every time I see if this is not null, if this is not null, and if this is not null, it's 3 times. Probability is quite high that I may rewrite this code in a little bit better way, because checking for null in 3 different places is quite a lot. And so here list is ended, but it's empty list. So how can we do here? One of the tricky things would be something like check here for list size initially. I would also do not like it. But definitely checking here for null, it is better than creating some fake previous order, which actually may happen in real life, and then all your fake orders will not work as required, because there will be actually such orders in your list. So one of things we may do, we may get rid of one of these checks here. Is first do this, but then again we need to do if has next, because list may be empty. Then we may get rid of this part and then we may move it around, but I do not. Okay. let's save it as a working variant. This number for activity. So I'm not sure that the total amount of code will be shorter, but if you do not like so many checks here, you can do initial setting for this order, like if has next, get first non-empty order. So then you can get rid of this part, and then you can put it inside, not here, if has next, and then you need to add this, and so you do all these calculations only if there is something to do with non-empty list. How can it can be still null here? Because if there has next, this, oh, it's not current order, sorry. We set up previous order initially before this loop. And yeah, and this also works. I don't know which of these is better. Because if you compare them, complexity is approximately the same. Only thing here, I get rid of some repetitive code here. I think I can make it a little bit shorter. I also don't need to do this check here anymore. So with this now I have, well, of course we can do it actually in integrated development environment. So if you compare this, what do we see? That with this maybe optimized implementation, I got rid of these repetitive checks. Not null, not null, not null. So that is good. What is not so good is that here I have one if. So I have one more deep loop here to go into this. And of course, loop embedded code inside conditions is also a little bit hard to understand. So therefore, I'm not saying that this is better in any possible way, but it is a little bit shorter, at least in terms of lines of code, and less repetitive, and therefore I still think that maybe this is now a little bit better implementation. Of course, here we have a little bit of repetitive code if has next and while has next. But I don't know how can you get rid of that, because you need to go into this loop and then you need to go somehow out of this loop to deal with this last order. So here you see you add orders inside this while loop, and then you still need to add it last time. But I think this is a little bit better. And so this would be about this particular exercise. Any questions or comments on that?